And it's my pleasure now to call up our next panel, where the topic will be the future of sustainability driving leadership on the path towards zero carbon economy. So I'd like everyone to please welcome me and joining to the stage our moderator, the Chief Science and Technology Officer for Energy and Environment at PNNL, Cindy Powell. Hi, Cindy. The Associate Director for Energy and Environment at Idaho National Lab, Todd Combs. The Dean of the College of Agriculture and Environmental Science here at UC Davis, Helene Dillard. And the Senior Partner at Breakthrough Energy Ventures, Cooper Rensler. So thanks everyone for joining us. Cindy, the floor is yours. Oh, do we have enough chairs? Oh, okay. Or I can pull up another chair for you.
No, excellent. Just fine.
Okay.
I've been sitting already a lot. All right, so everybody has their microphone. All right, we're going to begin this next panel, recognizing, as we've already been hearing a lot about this morning, we will hear for the next couple of days, just the importance of sustainability, achieving net zero emissions, essential on so many different levels. Not the least of which is the competitiveness and economic growth of countries and industries and et cetera. To achieve these kinds of emissions reductions by mid-century, that's the goal of the Biden-Harris administration, a net zero emission economy by 2050, echoing what is happening in the UK and around the world. It's going to require a lot, and time is short. Among the many things that are going to happen, we have to find a way to generate electricity, and a lot of it, with net zero carbon emissions. We're going to have to electrify everything that we can possibly electrify. So again, that's going to drive that need for even more clean electrons. But where we can't electrify, we're going to have to find alternative zero carbon or carbon negative pathways to enable those continued processes even without electrification. And then ultimately, we have to be able to upgrade our nation's energy infrastructure. We've got to be able to move those green electrons to where they're needed, when they're needed, in a reliable and resilient way. So the challenge is huge. Time is short. We're talking just a couple of decades to make massive changes across the spectrum. And this panel is going to start to address how we might do that. So I'm going to start with just a general question to all of you, and I'm going to take it, I think, in alphabetical order. So I'm beginning with Dr. Todd Combs from INL. Tell me what you believe are some of the key technologies and innovations that are going to be needed to achieve this net zero emissions, and how we can accelerate both their development and their deployment to meet these very aggressive timelines. Todd?
Thank you for that big question. So I think if we look at the Earthshots that DOE has let out over the last 2 or 3 years, that gives a good starting list of technologies needed in terms of hydrogen, long duration storage, direct air capture, enhanced geothermal, floating offshore wind, and industrial heat. What it doesn't include, which was actually included last week in a series of 3 liftoff reports. So liftoff for commercialization, really, to get to net zero, is advanced nuclear. So, in fact, right now at INL, our lab director and other nuclear senior leadership, as well as the senior leadership from the Office of Nuclear Energy, is there talking about this very issue, advanced nuclear and the strategy to get to net zero with it contributing. So you're going to hear about nuclear from the non-nuclear leader at the lab. So you might need to give me some grace. But from a perspective, think about nuclear. It's 20% of our base load. It's 50% of the non-emitting carbon electricity generation currently for the country. The liftoff report had a bunch of stats in it, what's needed for the future. One is to get net zero by 2050, 550 gigawatts to 770 gigawatts of additional clean, firm capacity is needed to get there. Of that, they say that we need about 200 gigawatts of advanced nuclear. So That gets us to about 300 gigawatts from our current 100. So it's a very heavy lift. Some of the things that are required with respect to that, how do we go from where we are to get to 200 gigawatts more and do it economically? So we got to ultimately, an nth of the kind advanced nuclear, get to about $3,600 per kilowatt from their estimations. Likely to start out at around the 6,200 to 10,000 range. So there's going to have to be a lot of technological learning that goes about, and it's going to be in different forms. So you're going to have microreactors, which are in the 1 gigawatt to 50 gigawatt range. You'll have small modular reactors in the 50 to 300, 400 gigawatt range, and then you'll have our typical 1,000 gigawatt scale reactors as well. Or actually, I'm talking megawatt. I mix megawatts with gigawatts. So replace the the gigawatts with megawatts. So large scale, gigawatt scale reactors, which are currently built today. So we've talked about already this morning human capital. So from a human capital perspective, to get there, will require about 375,000 additional workers in the nuclear industry. That's both technical and non-technical. For universities and tech schools, that's a lot of human capital that needs to be produced. We need to create the fuel supply chain for nuclear. Think about the Gen 4 advanced reactors. They all, most of them are going to require HALEU, so high assay LEU. So that's LEU, but enriched up to about 20% or so. Current supply chain exists in Russia. So we know there's issues relying on HALEU from a Russian perspective. So we're going to have to develop the supply chain on our own. And this is 5, 6, 10-fold increases in supply chains for fuel fabrication, HALEU, and other things to meet that 200 gigawatts of new capacity. Component supply chain wise, if you look at the Vogtle plants and recently developed, they had major issues with respect to the components of the reactors and having to do rework and it messing up the schedules and increasing costs. So that's another area. And then licensing. The NRC is going to have to get from the equivalent of about 0.5 gigawatt per year licensing manpower and capability up to, ultimately we need to get by 2030 to about 13 gigawatts per year of production of advanced nuclear. And if you delay that by 5 years, then you're looking at about 20 gigawatts per year production thereafter to get ultimately to be able to meet the 2050 goals. And then of course, you've got to talk about spent nuclear fuel. So we have to find a solution ultimately to deal with that. From a non-nuclear perspective, also as we think about electrifying things like the transportation system, we need infrastructure. So the Biden administration, we have 3 members of our team currently in the Joint Office of Energy and Transportation working on a daily basis to implement this, the deployment of 500,000 chargers, including level 2 as well as extreme fast chargers across the country.
Excellent. Thank you, Todd. So, Dr. Helene Dillard, your thoughts.
Okay, I'm going to give you my thoughts based on breakfast. Everybody ate this morning. We all need agriculture. And that is one of the areas where we can do some carbon reduction. Storage of carbon in the soil was mentioned earlier. And I would say that the key technologies that we're needing is more on solar, more on wind. Agrivoltaics is really taking off. We have faculty here working with large energy companies to find ways to grow crops or graze animals under solar panels and still be able to have that production at the level that we need it to be. So I would say more of the agrivoltaics is going to be needed. And advancements in energy storage is a huge one for us. When you're out in the country growing food, you need a place to store that energy that you're producing. And I would also say that there's some interesting things happening in Canada that I've been reading about, where they're actually capturing the heat from data centers, places where there's lots of computers. They're taking that heat and building greenhouses right next to it, and then using that to heat up the greenhouses and run some of the electronics there. And if we could do some of that, I think we could really move the needle quite a bit on helping agriculture. I would also say, though, that we're looking at what more we can do, the new innovations. We also need to work a little bit on reduction of demand. And I think that can come in the form of reducing the vehicles, miles traveled that we have. This is a campus where just about everybody rides a bike to work if they live in Davis or Woodland. And so I think that it can happen if we can get more public transportation, and then reducing and increasing our household energy efficiency. I was shocked. I was getting ready to buy a refrigerator a couple of weekends ago, and there were a lot of great refrigerators, and only a few of them were actually getting the Star Energy Award on those. And I thought, wow, these shouldn't even be sold at this point in time, but they're out there. They look great. They do everything you could possibly want a refrigerator to do. But again, I think we need to reduce our consumption as much as we can. I would also say, though, that in terms of ag, we need a workforce. And I think that also has come up quite a bit. And we can talk about that a little bit more on follow-up questions.
Sounds good. Thank you. So, Paul Monks.
If you were not to define 2050 as the goal, the answer I would give you, the transformative technology would definitely be fusion. Yeah, I mean, unlimited clean energy, who wouldn't want it? I think the exciting thing is that we're not that far away from it. There's kind of a fusion joke, isn't there? You're always 20 years away from fusion. But it's interesting, isn't it, that actually now in the US, you've got massive VC investment in fusion technology companies. In the UK, we're just starting a program to have the first commercial fusion power station on the grid by 2040. So we're investing in order to do that. So I think, maybe fusion's turn that corner around that. But it's not going to save us from 2050. Let's be honest. It's not going to save us from 2050. So to the other energy technologies, if I was doing a normal panel, I'd say absolutely hydrogen, and then wax lyrical about CCS. We've talked about long-term energy storage, which is absolutely critical to systems that have much more intermittency and variability on them. The one that really worries me and keeps me awake at night and makes me more awake as the days go on is how are we going to fly aeroplanes on sustainable aviation fuel, and where the hell are we going to get the e-fuels from? And the problem is twofold. To make e-fuels of any type, you need you need renewable carbon from somewhere, and you need energy, low carbon energy from somewhere. And we're looking at the UK at the moment at the SAFs question. If we were to try and produce the SAFs that we're now currently using in the UK, the aircraft fuel from SAFs that we're currently using, we'd have to convert all our food into fuel, all our food crops into fuel crops. It just ain't going to work. So there's a real challenge for technological innovation to somehow get to a question of how we can use these sort of e-fuels in a sustainable way. I think it's a mixture. That's like my systems problem. It's a mixture of efficiency, reducing demand, innovating around engine technologies to make them more efficient, finding more sustainable feedstocks and being able to create it from a mixture of CCS and from that. But there's a real problem here. The equation doesn't add up. If today, globally, if you look at it, the amount of aviation fuel we did today, if we were to get it from biomass, it would take 120% of the global production of agriculture. So that's not going to happen. How are we going to do that? So for me, the technological innovation is around that e-fuels piece and how we can make it more energy efficient and more carbon efficient in the way, or actually just make it add up in any way would be great.
Excellent. Thank you, Paul. And last but not least,
Sure,
Cooper.
cleanup crew. First, it's a privilege to be here with all of you. It's great to be back at Davis. I think I gave a talk here 5 years ago outlining what were the biggest gaps in climate innovation. Unfortunately, it's probably about the same answer today as it was 5 years ago. But it's also a real pleasure to follow Paul's conversation, who really pointed out that there's a systems issue here. I think the first issue is always defining the problem, and we got to be very careful that right here we're defining a net zero economy as the problem, whether that's in the UK context, in the US context. And I just want to call out that is an absolutely necessary and entirely insufficient way to achieve what we really care about as a climate outcome. Because the real meta system that we care about is the Earth climate ecosystem. And the reality is a huge chunk of emissions do not come from things currently embodied internalized inside of our economy, right? This is the externality of our time. This is the core underlying issue. And guess what? We don't currently value wetland methane emissions, but boy, are we going to care about that when it starts destroying value in our economy. But I'll answer the question in the context of a net zero economy. And in addition to everything you've heard today, I'll call out the ones that I think are the biggest, oh crap, it's really unclear for that maybe 50% of solutions that we don't yet have a marketable solution for today. Cow burps still remain number one in my mind. We're at UC Davis. Thank God we have Dr. Kebriab, Matthias Hess, Frank Mittlener here, right, who are leaders in the field. But this is a major issue. If cows were a country, they'd be the third largest emitter, right? I think beyond that, the big heavy industrial stuff is so tough. Cement, more than half of the emissions of cement production come from the chemistry, not from the energy use. Cement has the highest emissions per dollar value material we make. Steel is number 3, also a major issue. And again, we use carbon actually as an integral part of that process, not just as an energy source. Ammonia being number 2 there for fertilizer. And so I'll throw out a few other ones. Rice, since we're in rice country, I grew up 20 miles from here in rice country. That's a nice little one that's going to sneak up on us because of the methane emissions associated with rice. And I'd say with aviation, just to kind of follow up on that, about half the radiative forcing impact, which is what we really care about, right? We care about temperature and the effect that has on ecosystems. About half the radiative forcing impact of aviation is actually not energy use. It's related to aerosols in the atmosphere and related to effectively the creation of clouds that are precipitated out of the whether we use SAF or otherwise. That's a problem that is actually completely addressable. And yet we have not yet implemented the solution. So when I look at the world of half of the problem being potentially solved in the market today by existing solutions, I really focus on speed. I really focus on deployment. I really focus on changing consumer behavior and willingness to accept a better and cheaper solution. When we look at that 50% of the problem that's not yet solved, some of those things hypothetically could be within the current system boundary conditions a more profitable solution for the market. But there's a huge chunk of that we just need to be realistic about. It's almost thermodynamically prohibitive for them to be economically advantaged. That means we have to change the boundary conditions of the market. We really have to be thinking about a total systems view here. There is no version of a carbon capture and sequestration solution that has positive economic value without regulation or price on carbon. And I think we just need to really internalize that and accept that when we talk about what is necessary over the next 10, 20, 30, 50, 150 years of this continued issue, we need novel systems and novel institutions that are really at that interface of public and private, at that intersection of policy regulation, and then, of course, the mobility of finance. So I'll leave it at that. We could talk about all the other GHG issues that are out there, but I think that's enough.
Yeah, so why don't we go a little bit deeper, though, Cooper, and just talk a little bit more about what role specifically do consumers and investors play as we try to push to net zero emissions?
Sure, absolutely. I think we have a kind of a crisis of agency right now from the perspective of the consumer. This is such a massive problem. The very nature of the shape of this problem is that whatever you do doesn't really matter, and you're affected by what everyone else does in aggregate. And so how do we make choices as an individual when it feels like we have such limited agency over the real problem? And I think that there's a few kind of opportunities for the consumer, and there's obligations on behalf of us that are working in the sector across public and private to help enable consumers. The first is when there is a good solution that actually maybe is an advantage solution for you, either from a cost or a value perspective, we need to make it easy to make that green choice. And this is really building on what Paul described. There are wonderful, wonderful solutions that maybe improve the quality of air in your home, or reduce the cost of your transport. But we have barriers to making that choice, and that's a behavioral change issue there. And I think that we need to encourage consumers and enable consumers to make choices that are right for them. Of course, the flip side of this is that there's a whole set of solutions where consumers you would expect a consumer, if you wanted them to change behavior, to go outside of their incentive structure. Take the more expensive option, take the less convenient option. And that might work for us privileged folks in this room or in Silicon Valley or whatever it is, right? That is not a solution that sums up to a totality of solving the problem. And so I really do think it's incumbent upon us to enable more and more of the potential choices of the consumers, the individuals that are making the underlying decision, to align with the green incentive. And I think that the biggest tool that we have, if I think the average income is much higher than the median income on the planet. And so the power of the vote is on average much more powerful than the power of the dollar, even today in U.S. democracy. And so I really do think it's incumbent upon enabling the consumers to feel a narrative of agency in participating in the regulatory and the policy process by actually showing up and voting as well. On the investor side, I think you have an even more kind of constrained ecosystem in terms of what's the incentive structure. Consumers, they can value whatever they want. That's up to them. I can decide that I like a Tesla because it's pretty, and that doesn't change, regardless of whether or not it has a green solution or is economically advantaged. If you're an investor, your fiduciary obligation is to maximize returns. And so what's the role of investors? The role of investors, I think, is really around accelerating any transition that might occur by applying the lubricant of finance in the right place. And then there's a certain responsibility of having the vision and working in partnership with policymakers to understand what outcomes we're trying to drive towards and the resulting economic opportunities. But to me, that's really about scale and speed, and it's about changing the pace at which innovation is brought forward. But unfortunately, again, until you change the boundary conditions of the market of what is driving a profit incentive, investors are going to respond to the profit incentive. They're legally required to. And I'm speaking from the position of an investor that's in one of the more unique assets out there, and that we do indeed care explicitly about climate as a mandate. But boy, is it a big, big challenge. I think investors and consumers are crucial and highly insufficient without policymakers, scientists, and many other participants as well.
Thank you. So turning now to the big problem of agriculture. So again, Helene, going into a little bit more detail about the potential economic implications of a sustainable agricultural sector.
Great. I think that one of the things we're running into in agriculture is the cost of the new technologies. So right now I'm in the process of buying an electric tractor for the student farm. We've been on a waiting list for about 5 or 6 months, and the price for that tractor is about the price, and it's a very small tractor. In fact, it's going to be used on just 15 acres of the student farm. I have 2,300 acres of land. And so when I go to the rest of the land, I need a bigger tractor. I don't want to have to wait a year to get it, but I might. But I need it to have the power that the fossil fuel tractors can provide. And I think that that's where we really need that technology to speed up and help us with these things, because we could really reduce our fossil fuel use if we could go to electric tractors. There's also the problem of getting me the electricity I need to charge that tractor. When you're out in the countryside, you're not getting delivered a lot of power. So that's where our agrivoltaics are going to have to come in and help us. But I do think we need the engineering and more faster. So that would help us quite a bit. I'm also looking at, we're doing a lot already on the methane reductions. Not so much in rice fields. California State is working on that unfortunately, just with regulations, but not with solutions to really reducing it. But we're working quite a bit on methane reductions in cows. For those who don't know, when they burp, they put out a lot of methane. And we can control that with feed additives. Right now, the feed additive that works the best is a seaweed. And so we're working on what is it that's in that seaweed, because we know we cannot sustainably produce enough seaweed to feed to cows. But again, that's getting very, very close to use. We're scaling it now on large dairy farms. And I do believe it will be the solution to the cow burps. So I do know that we've got that almost under control. I think also, though, what we really, really need, and it's come up again and again, and so hopefully it makes the top 10 list on Chad's list, is funding for the research. It's not cheap to do this research. Every piece of equipment I buy is 10 times more than I thought it was going to be. And if we're going to train the workforce, if we're going to have young people going into these areas and trained, we can't put them on the 1940s farm. We have to have them on the 2030 farm. And so I know chancellors are working on this as well, but it's a very expensive thing to do. And then we also have our issues of equity. Who's going to benefit, small farms or large farms? And can we scale these things where everybody can benefit? We do need to pay more for food in this country. It's hard. It's a hard choice to make, but that's how you pay for these innovations. And we do need more private sector investment, as well as massive government investment in food and agriculture. I was heartened the other day when I got a call from someone in the military wanting to talk to me about food as a national security item. Yay! Finally, somebody recognizes this is really important for us. So I do think we're making progress on all these things. The other thing that we've done in California a lot is we've reduced our nitrous oxide emissions from agriculture through our irrigation systems. We're using a lot of micro irrigation. We've really got that thing under control. So at least we've done that. And so really all it takes is efficient nutrient management. Everybody's on it now because nobody wants to be the one that's producing the nitrous oxide. I do think you're right. We're going to have to work a lot on the rice industry. But again, they're doing a lot on their own and with the state government in California. So I'll stop there.
Yeah, thank you so much. So running out of time, but real quickly, Todd, Dr. Ashby reminded us about the tremendous capabilities resident in the national labs this morning earlier. And I'm just curious, how do national laboratories collaborate with the private sector and other stakeholders to really push innovation forward and accelerate technology acceptance?
So in a variety of ways. If you think about everything that's being funded right now, these really large-scale public-private projects and things like the Advanced Reactor Demonstration Program, these are $4 billion projects. Industries contributing $2 billion, the government $2 billion. You're going to have lab staffers embedded in all these projects that are right there on a daily basis, providing R&D and decades of experience in their research areas to really boost these projects and get them going where they need to go. Same thing with hydrogen hubs. We're currently on 3 hydrogen hub teams that are shortly due with their final proposals. The national labs have a lot of user facilities at various scales. You have the really massive user facilities like the Advanced Photon Source at Argonne, Splayson Neutron Source at Oak Ridge with a former director sitting here in the front table. But you have, for instance, at our laboratory in my area, the Biomass Feedstock National User Facility, which is a energy efficiency and renewable energy facility. We work on the early stages of the supply chain. How do you bring in biomass from the field? How do you optimize it? How do you get informs to produce so companies can produce biofuels and other products? That work actually is sort of morphed over the last 2 or 3 years. We're doing about 50% of our work related to sustainability in the area of municipal solid waste. Same thing, how do you bring MSW in, process it in our facility, and then get it to industry so that they can build value-added products of it. I'll finish with another third role common with the national labs is third-party validation. So I was at a meeting with Fossil Energy Carbon Management last week with the tribes, a number of Western tribal nations, and they made the point of, we don't trust these vendors who come to us with technologies and say you should deploy them. Many times very expensive technologies. We need somebody to give us an indication that these are actually ready to go. So one of the things we do is third-party validation. For example, last year we spent a year with a 100 kilowatt Bloom high temperature steam electrolyzer, putting it through its paces, thousands of hours of testing, examining stacks, providing them data. Actually, it performed very well. And we're in the process right now of scaling that up to be able to support hydrogen hubs in the hydrogen industry by being able to validate and test multi-megawatt scale electrolyzers, which will be producing hydrogen at the 5 to 6 metric tons a day at INL in the near future.
Thanks, Todd. So I want to give Paul 1 minute for the final word. So I'm really intrigued by this notion of making a green choice the obvious choice. And I'm curious, how can the US and the UK learn from each other as we make progress towards zero emissions?
Yeah, I think that's a really interesting question. I'm going to come back to something earlier. One of the things we're talking about in the UK is if you suffer an environmental disbenefit, i.e. you have a wind farm on shore, you maybe should get cheaper energy because you're in that area. So I think there is making the green choice the right choice, lots of ways, and it is incentivizing the customer. Over and over again, actually, we find in the UK, the public appetite actually for green choices is actually greater than the government appetite for it over and over again. And I think we've got to harness that. And I think it's giving opportunities and understanding. You go to green finance, there's more green finance available than there are green investment opportunities. What sort of mad world is that we live in? There's actually capital sitting idle because we can't find the investable opportunities that are green. You know, so I think there are many, many opportunities out there. I think to make green choice the right choice, I think you are absolutely right to make the point that we've not also got to there's a phrase they use into the green citizens that are disenfranchised, the left behind. We mustn't create another left behind class as we decarbonise our economies. That is really, really important. So it's got to be green choices for all, I think, that is part of that and availability. And I think that getting to the point that the role that governments, federal, local and national governments have to play, state governments in your case, have to play across that and build up an ecosystem where the green choices are in fact the right choices and reduce the green premium. The green premium is, at the end of the day, the consumer choice will become the natural choice when the green choice is cheaper than the alternative one. And I think that's use your market mechanisms. You're the greatest country in the world at market mechanisms. So use your market mechanisms to rate those choices the right ones.
So Cindy, can I add in one thing on the left behind class? So it's been a theme, I think, in the first part of this meeting. And I can tell you, having been at that tribal meeting last week, we're already failing. We had the Navajo Nation there, Hopi tribes, and I can't say anything other than that they were talking with desperation. The Navajo Generation Station closed down, and the Hopi tribe relied on it for something like 86% of their revenue. So they've got families who are desperate. They can't provide electricity. They can't provide for their families by this coal plant going down. So we really need to immediately start acting on this. We're already leaving groups behind.
All right, so thank you all very much. I'm going to turn it over to the next one.